Hello and welcome to section 2. In this section, we are going to talk about API Gateway. Now you understand what serverless is and you have an idea when to use it. So in this section, we are going to take a look about event-driven architecture that I mentioned that serverless is an event-driven architecture. So we will get into that. We will talk about what is API Gateway, and we are going to explore what are some AWS Lambda events that we saw when we were making our first AWS Lambda, that we had an event there. So we are digging into that. And then we are going to create a Lambda trigger by API Gateway, understanding what comes in the event and sending back a response. In this video, we are going to talk about what is event-driven architecture. And we are going also to talk about some patterns to architect our AWS Lambdas. This is going to be a little bit academic video, but it will help you to understand the next videos as we go on. An event-driven architecture is an architectural pattern. It consists of event producers and event consumers. Both of them are very decoupled from each other, so producers don't know which consumers are listening. Usually you can have a producer and many consumers. In this example, the event can be a change in the state. Events are streamed out and consumers are listening to those events. So in this case, the item is sold will be sent to 3 different consumers. One can be inventory system, the other one can be like an order management, and the other one can be some kind of analytic system. So we have 3 different systems that are consuming the same data and doing different things with it. Let's talk about the advantages. One of the advantages is that the system is very decoupled. You can add new services to your system and the system will still work and you don't need to create very complex integrations. There is no point-to-point integrations. So you can add new consumers and producers to a system with no problem. Usually this is called like kind of real time, because consumers can respond to events immediately as they arrive. These systems usually tend to scale and distribute much better than systems that are much more coupled, because all the different bits and pieces can scale in a different way according to their needs. And as I saw in the example, the subsystems can have independent views of the different event data. So now let's talk a little bit about the AWS Lambda Patterns. This is about the amount of events that can trigger a function. Our functions are event listeners, and other functions or services can be event producers. We'll be talking about 3 patterns. I will call it the serverless monolith, serverless microservice, and the serverless nanoservice. The first one is the serverless monolith. This is the one you don't want to use. This is more, I will call an anti-pattern. You have one big function and all the events of your system are pointing to it. We can say that it has an advantage that it has less functions to manage because you only have one. And it's probable that the Lambda is always ready to execute because it's always called. So performance should be okay. When we say that the Lambda is ready to execute, we also say that the Lambda is warm. What it means that a Lambda is warm? In the video that I explained how serverless code executes, I told you that the function as a service platform will create a new virtual container and deploy the code of the AWS Lambda every time it's triggered. That is kind of true, but what happens in reality to make it more performant is that AWS Lambda will keep the same virtual container alive for a longer period of time, around 5 minutes, unless there is some new function to be deployed. When this happens, it says that the container is warm, and there is less time for the moment that event is triggered than the function responds, because there is no need to deploy that function into the container. So let's go back to our disadvantages. This has a lot of disadvantages. It's very prone to bugs, because we need to handle all these events in one big function. And every time you deploy, you will need to test everything, because everything happens in one function, so you're losing that kind of benefit of having independent components. Also, deployments are very slow because the function is very big and it will need to get deployed into the microservice, and that will take a while. And sometimes the function can be so bigger that the files are exceeding the allowed size by AWS. So don't do this. Serverless monoliths are a no-no. The next pattern I want to talk about is the serverless microservice. The serverless microservice is a group of events that trigger one function. Those events are grouped around one resource. So it's like a microservice kind of concept. It's recommended that your serverless projects are small, so that these functions are small. I like to have one serverless project that comprises a microservice that does only one thing, like modify customer information. In the picture we can see that there is two different functions, the order function and the client function. If I was making these, I will put them in different serverless framework projects, but you can decide. If you like to have bigger serverless framework projects, you can have more than one microservice inside, and you can have multiple lambdas with multiple events each. But sometimes for clarity, it's better to have them separately, unless they are really using the same libraries and things like that. But I try to have them in smaller bits. It makes it easier to test and to manage that code. So in this case, we have two functions, and we can have more. And each function is taking care of a resource. In the case of orders, it's taking care of the order function and the orders table and everything that is related to orders. And then the client is the same, taking care of clients and taking care of the database that is behind. And there are events that are asking for orders, deleting for orders, creating orders, and so on and so forth. So you can see that this is much better than the previous pattern. How it goes that in the handler of this function, you will need to have some way to detect which event is triggered, so you can respond correctly. Some advantage of this is that you will have less lambdas to manage, because you will have maybe 10 events and maybe 3 lambdas. The deployments are faster because the lambdas will be smaller than in the monolith case, and it's probable that the lambdas are warm whenever an event is called, because, for example, maybe delete is not called that often, but get is always called. So the order function will be already deployed in a container because of get, and when we call delete, it will be already ready for us. Some disadvantages, that this is prone to bugs, because we need to manage this event selection quite tidy. So if it's not managed correctly, we can end up in bugs. And the function package, it can get bigger, so it can make the deployments slow. And this will make longer time for the container to get started. So you need to analyze when is a good moment to use this pattern. The last pattern is the serverless nanoservice. One event, one lambda. There is one event for each lambda in the system. Everything is very isolated. I call it the nanoservice pattern. I don't know if there is a better name for this. So you have one function that does only one thing. Event get orders is the event, and it will call the function get order. And the same for delete, and the same for create, and for anything. The advantage of doing this is that everything can be deployed independently. If one function changes, the others don't get affected. Each Lambda function will handle a different event, so you don't need to have any code to handle which event is being called, so there will be less bugs. And that will make the handle file simple. Some disadvantages that you will end up with a lot of functions to manage and to monitor. And if your lambdas are not called that often, they will be called, and sometimes performance can be compromised. I like to use myself the microservices and the nanoservice combined. Depending if it's one kind of events or another, I will use one or the other. So for example, in the case of HTTP events, I will use the microservice pattern. I like to group all the CRUD operations like get, put, delete, and post messages into one function. When it comes to other kind of events coming from the database or events coming from S3 or from a queue, I like to have it more in a nanoservice matter. And then I create the grouping by organizing the serverless framework project. I will show you how to do this when we get into our application in the next video.